Hi, I'm Sam Noland, Sales Engineer with nexAir. Today we're going to be discussing the physics of welding gases. So to start out with the physics of gases, we have to understand what an atom is. An atom consists of a nucleus containing protons and neutrons, protons being positively charged particles, surrounded by rings of electrons. These are negatively charged particles. The interaction and flow of electrons is what causes electricity, and this is the key to welding. When an electrical arc is established, electrons flow from the negative pole to the positive. And as the electrons flow, they have to be able to move from atom to atom. So in welding, it needs to go from a negative electrical pole to a positive pole. This flow requires atoms in the intervening area. To establish this, we use welding gases. The main gases used most often in welding are CO2, carbon dioxide, argon, helium, and oxygen. These four gases each have many different qualities that affect both the weld and the electricity. So first we need to have some basic definitions. Voltage, it can be considered almost a pressure. So for example, the pressure of a hose. That's the same thing. The flow of the water is the flow of electrons. Amperage is a measure of the number of electrons to pass through a certain point per second. 1 amp is equivalent to 6.25 billion electrons crossing a single point in 1 second. This is a massive amount of movement, but when you're talking about atoms, which are so tiny, it's not really that much. And so amperage is typically rated between about 40 and 400 amps for your welding cycles. Resistance in the line can always be a big issue, so it's very important to be sure that all ground cables and welding cables are good. There's no dirt or grime, and your welding gases flow properly. Any of these can add something in the line that will stop the flow of electricity. So when welding, we often refer to straight and reverse polarity. Straight polarity, the easiest way to think about it, is to draw a straight line. DC electrode negative. Always remember the straight line is negative. DC electrode positive, most commonly used in GMAW or MIG welding, is DC electrode positive. And so when we talk about MIG welding, we want to talk about what is transferring the electrical flow. So if you're working with DC electrode positive, you'll have a welding wire, which will be positive, and you'll have your base metal, which will be negative. This intervening area, we don't want it to be air. Air does not transfer the electricity very well. What we want it to be is our shielding gas. Different shielding gases have different ionization potentials. Ionization is the ability for the electrons to be taken from the atom and transferred on, thus creating your current flow. So if we were to be welding with pure helium, we'd have our nucleus with protons and neutrons surrounded by your electron cloud containing 2 electrons. And this is the entire area containing many atoms of helium. These atoms as they heat up begin to release the electrons as the negative charge flows through the gas. That is what creates the amount of heat that helium has compared to, say, argon with 18 electrons, where not as much heat is required to break the electrons loose. The importance of using the proper polarity in welding lies upon which direction the electrons are flowing. In DC electrode positive, which as I said is MIG welding, the electrons are flowing from the base metal to the electrode. This gives it a faster melt-off rate, more deposition, and the positive ions are then drawn to the base metal. These ions give it the cleaning factor that we really need to make sure the surface of the base metal is weldable.